Okay, so number 6. I mentioned that you could factor that. That's going to factor to x squared plus 2 and x squared minus 2, and you could factor the second one with the square root of 2, but that gets a little messy, so we're going to not do it that way. We're going to go x cubed plus 1 over x squared plus 2 and x squared minus 2. And we're going to try to do it with this, and so we're going to get, since they're both quadratic factors, we're going to get ax plus b over x squared plus 2, and we're going to get cx plus d over x squared minus 2. So we're going to need to take the first one times x squared minus 2, and the second one times x squared plus 2, and so we have x to the thirds. One of them equals a, not b, and plus c. X squareds, 0 of them equals, we're going to get b. X squareds here, and that's 2 x's, and constant, nope, and then x squareds here, I'm going to get d of them. And x's, I'm going to get minus 2a. X's, there's none here. Minus 2a. And x's, we're going to get 2c. C. And the constant, we're going to get minus 2b. And plus 2d. And over here is 1. So, calculator, second matrix, edit, A, 1, 0, 1, 0. Nope. It's a 4 by 4, sorry. Whoops. Move up here. 4, enter, and then we got 1, 0, 1, 0. Second row is 0, 1, 0, 1. Third row is minus 2, 0, 2, 0, and the fourth row is 0, negative 2, 0, 2. And matrix, edit, B, and it's a 4 by 1, and it's 1, 0, 0, 1. Second quit, A inverse B, and we get 1/2 minus a quarter, 1/2 plus a quarter. So we get integral of 1/2 x over x squared plus 2 plus 1/2. B was minus a quarter, minus 1/4 integral of 1 over x squared plus 2. And then we're going to get plus 1/2 integral of x over x squared minus 2 plus 1/4 integral of 1 over x squared minus 2. Okay, substitution will do this one, because we'll get a 2x when we let u equals x squared plus 2, du will be 2x dx, and dx will be du over 2x. Oh my goodness. Excuse me. So this becomes 1/2 integral dx over u, and dx is du over 2x. I'll take a little slower on this one so you can see all this. And so this is 1/4 integral of 1 over u, which is ln u, or x squared plus 2. That's that one. I'm going to jump over to this one. If I let u equal x squared minus 2, du would also be 2x dx. dx would be, oops, sorry, got off the screen. dx would be du over 2x. And I would have 1/2 antiderivative or integral of x over u, and dx would be du over 2x. The x's would cancel, and I get 1/4 antiderivative of 1 over u, which is ln u. And now we got these two. And they're going to be trig subs. This one, can you see that? Yeah, go right to there. That's right at the top of the screen. So we're going to do, they're added, so I'm going to put x and the square root of 2, and this would be the square root of x squared plus 2 theta. Tangent of theta is the simplest, that's x over the square root of 2, and secant squared theta d theta, taking the derivative, is 1 over the square root of 2 dx, and the mess, square root of x squared plus 2 over the square root of 2, this over this, is the secant of theta. So this becomes, so we got the minus 1/4, we got to remember, I'll put that here, minus 1/4 of what I'm going to get out of this. So minus 1/4 parenthesis plus 1/4 we got for that one, and then we got this one here, but we'll get this here. So it becomes the antiderivative 1. The mess is square root of 2 secant, well, the square root of the mess, and there's no square root, so I got to square that. So it becomes 2 secant squared theta, and the dx is square root of 2 secant squared theta d theta. The secant squareds cancel, and I get square root of 2 over 2 integral of d theta, which is theta, and theta is the arctangent of that, so I get square root of 2 over 2 arctangent of x over the square root of 2. Now this one, we haven't done many of these. The positive part of this is there, so we're going to do, that has to go on the hypotenuse, so that's x. So we're going to put the square root of 2 here, and so this side becomes the square root of x squared minus 2. To get it to be x squared minus, as opposed to 2 minus x squared, that could be the x over here, but this has to be the other way around. So we get secant theta equals x over the square root of 2, 1 over the cosine, secant. So the derivative is secant theta tangent theta is 1 over the square root of 2 times dx, d theta, sorry. And the mess is, doing that over that, is the tangent of theta is the square root of x squared minus 2 over the square root of 2. So I'm ready to make the substitutions. So I've got the 1/4. And then I'm going to figure out that antiderivative, and I'm going to do that by saying it's the integral of 1 over that mess. Well, that's this squared, so I'm going to put the square root here, and I'm going to square that, so I'm going to get 2 tangent squared theta. And I'm going to get the dx, which is going to be square root of 2 tangent theta secant theta d theta. One of the tangents cancel, and I can pull a square root of 2 over 2, factor it out of the integral, and so I have secant 1 over cosine theta, and 1 over tangent, which is sine theta over cosine theta in the denominator, so it becomes the other way around when I bring it to the numerator, d theta, and the cosines cancel, so I've got 1 over sine, which is cosecant theta, that I have to integrate. So I'm going to resort to my cheat sheet for cosecant, and that's, get that in there where you can see it, there we go. That's going to be square root of 2 over 2 ln cosecant theta minus cotangent theta, and plus c, we're going to put on at the end. And so now to go to here, the cosecant is not the sine, but the backward sign, the reciprocal sign, so it's going to be x over that. Oh, ln, I forgot the ln. ln, absolute value, cosecant is square root of x squared minus 2 over, no, x over that. Got to get it the right way. That over that's the cosecant, and the cotangent's going to be square root of 2 over that same denominator, x squared minus 2. Messed that up a little bit there, but hopefully you got that. Plus c. Tad messy for that one. Okay. Now let's do some trig sub. Well, we've been doing trig sub all along here, but we're going to do some trig sub on this. So let's move it down. Oops, too far. There we go. Come on. There we go. Okay, so I'm going to, this is a subtraction, so the positive part, the 9, would, square root would be on the hypotenuse, which would be 3. And so I put the other part on the opposite, which would be square root of 5x, and this side would be 3 squared 9 minus the square root of 5x squared, which is 5x squared. And therefore the sine of theta is square root of 5x over 3, taking in the derivative, cosine theta d theta is square root of 5 over 3 dx, and the mess would be cosine theta is the square root of 9 minus 5x squared divided by 3. So this integral would change to, see, x squared, multiplying both sides by 3 over the square root of 5, and then squaring it would be 9 over 5 sine squared theta. That's the x squared. This mess would be 3 cosine theta, but I'd have to square it, so it's going to be 9 cosine squared theta. And the dx becomes 3 over the square root of 5 cosine theta d theta. So one of the cosines cancel. And let's clean to see. The 9's would cancel. That 5 would come out in the denominator. And this would be 3 over the square root of 5. And no cosines, so I got sine squared over cosine. Sine squared theta over cosine theta. But sine over cosine is tangent. That's not going to cancel very well. If I let's see. What should I let u be? I think I can do this with a u sub if I make a good choice here. Let's say let u be thinking about this. If I let u be sine, its derivative would be cosine, and I get cosine squared in the denominator, which is 1 minus sine squared, so I get 1 minus u squared in the denominator. That might work. If I let u be cosine, then this would be, I'd get a sine to cancel. I get sine over u, and sine is not so pretty. Okay, I think I shall use, actually, I think I'll do this. I'm going to use a reduction formula. Integral, I'm going to call this sine squared theta cosine to the minus 1 theta d theta. And I'll show you how I can use a reduction formula on that. Now, I want the sine squared to disappear. So I'm going to do the one that lets the sine go down by 2. So that's what I'm going to use, this one. So I'm going to get, see, that's 3 over 5 square root of 5 all times. So m's going to be 2 and n's going to be negative 1. This thing doesn't say you can't let n be negative 1. So it'll be minus, and sine reduced by 1, which would be sine theta. And the cosine increased by 1, which would be to the 0, so I get no cosine, over m plus n, which would be 1, plus m2 minus 1, which is 1, over m plus n, which would be 1. So 1 over 1, which is 1, integral sine to the 0, which is gone, and cosine still to the minus 1 of x dx. Minus means 1 over cosine, not the inverse. So 1 over cosine is secant. And I know the integral is secant from here. So this will become 3 over 5 square root of 5 negative sine theta plus the integral of secant theta is ln secant theta plus tangent theta plus c. And now we can go back and change these using our triangle. So we got 3 over 5 square root of 5. Negative sign would be negative square root of 5 x over 3 plus ln. Secant is hypotenuse over adjacent. 3 over the square root of 9 minus 5x squared plus tangent, which is square root of 5x over square root of 9 minus 5x squared plus c. I drew it backwards. I don't know why. I was thinking of the bracket here. So that would be that one. That was a tad tricky, using the reduction formula on something with a negative exponent, but you can do that. All right, so let's now do, let's see, what's the next one? Hopefully it won't be as messy. So we got integral, we got a 7. I'll just pull that out right away. 1 over x square root of x squared plus 16 dx. And so if I let u be this, we'd get an x down here, which would make it an x squared. Wouldn't be bad, but it wouldn't be the easiest. Trig sub would be a little bit easier, so, and they're added, so I can put the x here and the 4 here, and I would get x squared plus 16 square root on the hypotenuse. So I'm letting the tangent of theta be x over 4. And so secant squared theta d theta equals 1/4 dx, or multiplied by 4 secant squared theta d theta equals dx. The messy would be secant theta is the square root of x squared plus 16 over 4, and I could multiply by 4 to find out what the messy was. So this becomes 7. 1 over x. X is 4 tangent theta. And the square root is 4 secant theta. And the dx is secant squared. 4 secant squared theta d theta. Dx is 4 secant squared theta d theta. All right, let's simplify using all our fun trig that we learned. 4 cancel, and a 4 would come out, so I'm going to get 7 4s. One of the secants cancel, so I got secant, which is 1 over cosine theta, and tangent is sine theta over cosine, which would put the cosine up here. So cosines cancel. I get 1 over sine, which is cosecant theta. And we have a formula for cosecant. And we get 7 over 4 ln absolute value of cosecant theta minus cotangent theta, and 7 4 ln cosecant theta is the reciprocal of the sine, so it's the square root of x squared plus 16 over x, hypotenuse over opposite, and cotangent is adjacent over opposite. And finally, this one. So we have the antiderivative, we can pull out the 11, 1 over x third square root of 4x squared minus 16 dx. So I'm going to make a triangle for a trig sub. And this is the positive part minus this, so I'm going to put 2x on the hypotenuse, put 4 on the adjacent, so I can put the messy on the opposite that has an x, and that'll be 4x squared minus 16. So secant theta is hypotenuse over adjacent, 2x over 4, or 1/2 x. The derivative of secant is secant theta tangent theta d theta equals 1/2 dx, or 2 secant theta tangent theta d theta is what dx can be replaced by. An expression for the messy, doing it this way, the tangent of theta is the messy over the 4. And so this becomes 11 antiderivative 1. The dx is 2 secant theta tangent theta d theta. The x to the third. Okay, so if I multiply by 2 secant theta is x, so that would be 2 secant theta to the third. And this messy is 4 tangent theta. So, cleaning this up, tangents cancel. 2 goes into 4 to make 2. 2 to the third is 8 times another 2 is 16 that I'll pull out. So I'm going to have 11 over 16. Tangents are gone. I got a secant here that'll cancel one of the secants here. So I'll have the integral of 1 over secant squared theta d theta, and 1 over secant squared is cosine squared, so I'll have 11/16 integral of cosine squared theta d theta, and we have a formula for cosine squared. It's going to be 11/16. Cosine squared is theta over 2 plus 1/2 sine theta cosine theta plus c. So what's theta? It's the arc secant of 1/2 x. And we got a half of that, so 1/2 arc secant of 1/2 x, or x over 2, plus 1/2. What's the sine? The sine is the square root of 4x squared minus 16 over 2x. And what's the cosine? It's 4 over 2x. And we're done.